Hi, welcome to solveandgo.com. In this video, I'm going to give a third example of using the definition of the derivative to find a derivative. This one will be a little harder, require a trick. So, again, the problem is to use the definition of the derivative to find f prime of x, where f of x is the square root of x. Okay? All right, so let me recall the definition. F prime of x, make that a little clearer. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x divided by h. Okay, so let's apply this definition to the function. We have f prime of x equals the limit as h goes to 0 of the square root of x plus h, so this is f of x plus h in our case, minus the square root of x divided by h. Now what happens when we plug h equals 0 into our limit expression? We're going to get 0 over 0. So we need to do something to change the form of what's within the limit to something that we can evaluate and actually get a number or a function out. So the trick here, as is often the case with radicals, is to rationalize or multiply by what's called the conjugate. So what we do, we take root x plus h minus root x divided by h, and we multiply by 1, but in the form of the conjugate of this expression here. The conjugate is x plus h under the square root plus root x. So we just change the sign here. Okay, and then we can't actually change the function, so we need to divide by the same quantity. That's x plus h plus root x as well. Now, what you see when you multiply the top here is that any terms involving the square root disappear, and what you get, you should perform this calculation on your own. You get this term minus this term under the square root. Okay, and then what's on bottom is h times root x plus h plus root x. Okay? All right, let me erase what's on top here. And what we get is the limit as h goes to 0 of h divided by h times root x plus h minus root x. Okay, the h's cancel, which is what we want. And let me erase what's below. We don't need it anymore. What we're left with is the limit as h goes to 0 of 1 over root x plus h minus root x. We can plug, plus is what I copied it wrong. This is a plus sign. And what we're left with is 1 over root x plus root x, which is 1 over 2 root x, which can be written as 1/2 x to the negative 1/2.